Hey, Algebra students, in this lesson, we're going to be talking about graphing linear inequalities. Now, anytime you've made a graph for an inequality in the past, it's been the graph of a number line. And we put a number somewhere on the number line, shade to one side, and call it a day. Now, think about that. When you graph on a number line, how many numbers do you mark on the number line? Just one place, right? One place at a time one number identifies each point on a number line. So number lines are really meant to identify just one number at a time. And sure, we may have graphed some compound inequalities on number lines and put more than one number, but we always marked one number at a time. What if we don't have just one variable in an expression that we can graph on a number line? What if we have two variables, x and y? And x and y can't just be represented by a single number. They have to be represented by a coordinate pair of two numbers. That's what we're going to be doing in this lesson. We're going to learn how when we graph with two variables, we're no longer going to be on the number line. We're going to be on the coordinate plane, and we're going to see what that looks like as we go through this lesson. Okay, so the first three questions are actually quite easy. We need to determine if each ordered pair is a solution to the given inequality. So is 2, 6 a solution to y is greater than 3x minus 2? Now, before we go any further, I'm just going to graph that in GeoGebra. We don't really have to do this, and you certainly wouldn't have to do this for your problems, but it's actually nice for us to be able to visualize exactly what it is we're looking at. Okay, so let me just grab that exact equation once again. Y is greater than 3x minus 2. That's what we're going to start by graphing here. All right, we're just starting up our calculator. Y is greater than 3x minus 2. Now notice that when I graph an inequality on a coordinate plane, I get a whole region of the coordinate plane that's shaded. We're going to see why that's significant in just a second. Now, let's just take a look at this. Is 2, 6 a solution to this? Well, I'm going to plug in 2 for x and 6 for y and see what I get. 6 is greater than 3 times 2, which is 6, minus 2, 4. Is 6 greater than 4? Yes, 2, 6 would be a solution to this inequality. Hey, let's just go back to our graph here. Where is 2, 6? 2, 1, 2, 3, 4, 5, 6. Notice that 2, 6 is in the shaded region of this graph. The shaded region of a graph, we're going to find out, means that anything that's shaded is a solution to our inequality. All right, let's take a look at the next one. Y is less than negative 4x plus 1. And we're going to plug in 4 for x, 1 for y. Is 1 less than negative 4 times 4, which is negative 16 plus 1, negative 15? 1 is not less than negative 15. So I would say no, B is not a solution. Let's graph it. Okay, so it's y is less than negative 4x plus 1. So we're going to take this one and we'll just change it. Y is less than negative 4x plus 1. There we go. Now, let's just see what happens on this graph when I plug in 4, 1. Notice that's not in the shaded region of the graph because it's not a solution to the inequality. Okay, so for number 1, we said yes. For number 2, we said no. Let's take a look at 3, letter C. Negative 6, 2 for y is less than or equal to 5. There's not even an input for x on this one. So it doesn't matter what x is. All that matters is what y is. And is 2 less than or equal to 5? The answer is yes. 2 is less than 5. All right, so let's go ahead and plug this. Y is less than or equal to, I think I know how to do that. Y is less than or equal to 5. Okay, there we go. So this is our new graph. And then let's see, is the point negative 6, 2 in the shaded region? Why, yes, it is. And it should be a solution. We plugged it in and found out it was a solution. Let's just make sure it's a solution. There we go. All right, letter D asks us to graph each inequality. To graph each inequality, what we're going to do is put the inequality into slope-intercept form, and we're going to graph it as if we were graphing a line. So this is going to be 5y is greater than or equal to negative 4x minus 10. Notice I subtracted 4x from both sides, get y on a side by itself. I have to have y on a side by itself in slope-intercept form. But wait, we're not done yet. This is going to be y is greater than or equal to, okay, and then we're going to put in, we need to divide everything by 5. So it's going to be negative 4/5 times x, okay. We're just going to leave that looking like it does, minus 2. This should be the same equation. Now I can graph this. I'm going to graph this using slope-intercept form. I'm going to put a point at 0, negative 2, the y-intercept. And then I'm going to count down 4 over to the right 5. Down 4 over to the right 5. Okay, let's see if that's how this one actually looks. Notice that it crosses at 0, negative 2. Negative 2 is the y-intercept. And it goes down 4. Oh man, that goes off the graph over to the right 5. Now that's how I would have done it. We could go up 4, 1, 2, 3, 4, but then we have to go over to the left 5. 1, 2, 3, 4, 5. You see it passes to that point. I would graph several of those points just from the y-intercept first and then using the slope. And then we have to make some choices. First of all, when we graph a line, when we're graphing an inequality, we need to decide whether we're going to graph a solid line like here in letter H, you see the solid line, or a dotted line like in letter I. Solid lines mean that the points on the line are a solution. In other words, it means that the y value is less than or equal to. Dotted lines mean the points on the line are not a solution. So that's just going to be the less than sign or the greater than sign, not the equals. All right, what do we have in D? Do we have less than, greater than, less than or equal, greater than or equal? Notice this is a greater than or equal to. So I'm going to shade all points greater than or equal to this line. And that's going to include the line, solid line. So I'm going to draw the solid line first. Now, the next thing I'm going to do is I'm going to choose at least 1 or 2 points to plug in and see if they fit the inequality. I'm going to plug in 0, 0, okay? If I plug in 0, 0, is the inequality true? Is 0 plus 0, which is a 0, is that greater than or equal to negative 10? Yes. Hey, if I choose a point somewhere on the graph and plug it into my inequality, and it turns out that that point is a solution to the inequality, what I do is I shade all the points on that side of the graph. And that's going to give me my answer for D. So the 3 parts, the line, whether the line is dotted or solid, and then shading either on the top or on the bottom of the line, depending on which side has a point that solves the inequality. Hey, what if I would have chosen a different point? Let's say I chose negative 2, negative 2 to see that. Notice that's in the non-shaded region, okay? Hey, what if I chose that point? Well, if I plug in negative 2, I get negative 8 minus 10 is negative 18. Is negative 18 greater than or equal to negative 10? No. If I choose a test point on one side and it turns out it's not a solution to the inequality, that tells me something. I need to shade the other side of the line. So you're going to just pick a test point and plug it in. Let's do letter E. X is greater than 6. All right, so first of all, let's just put a line at X equals 6. That's going to be a vertical line way over here. It's actually going to be off of this graph. Maybe I'm going to scrap my plans to put it on this graph, and we'll just show the picture of it here. So notice that this is the line, X equals 6. It's this vertical line. Now, is X actually equal to 6? No, X is less than 6. Notice it's not less than or equal to, it's just less than. So I'm going to shade, instead of by putting a solid line here, I'm going to put a dotted line here, okay? And I'm going to choose a point on one side of the line. I'm going to choose the point 8, 0. 8, 0. Now, I can plug in an 8 for x. There's no number to plug in for y, so 0 doesn't even matter. Is 8 less than 6? The answer to that is no, it's not. So that means I have to shade on the other side of the line from 8. I'm going to shade everything to the left because any point in the shaded region will be a solution. Let's try one of them. What about negative 8, 0? Well, if I plug in negative 8 for x, yeah, that's less than 6. That works. All right, letter F. Graph each inequality using a graphing calculator. Good thing I got good old Algebra here, so I don't have to worry about an expensive graphing calculator. I'm just going to go ahead and delete this function we had in there. And now we're going to graph 4x plus 2y is less than or equal to 6. No need to even put this in slope-intercept form. We can graph this as is. 4x plus 2y. So I'm going to type 4x plus 2y is less than, I use the left arrow, or equal to, I just type in the equal sign right after it. It puts the nice less than or equal to sign in there. And it's going to be less than or equal to 6. Oh, hold on. I think I lost it. Let's try one more time. 4x plus 2y is less than or equal to 6. Enter. There is our graph. Now, notice that the line was shaded. It doesn't really show it very clearly anymore, but this line here was shaded before. Okay? And not only that, all points to the left of the line are shaded. That's the solution on a graphing calculator. Let's just make sure it works. Same thing. Okay, let's move on. Letter G. Y is greater than 2x plus 6. Y is greater than 2x plus 6. Okay, notice the dotted line. I'm going to hit enter. There we go. And let's make sure that this appears the same way on a graphing calculator. There it is. Hold on one second. Y is greater than 2x plus 6. Oops, I entered the wrong symbol. You probably caught me and were screaming through your computer at me. Notice that changing the direction of the sign just changes which side of the line is shaded. All right, that is the correct way to graph it. All right, and then write an inequality for the region graphed on each coordinate plane. So the way that this is going to work is, first of all, we need to start by writing an equation for the line. In letter H, this is one of the easiest line equations to write. It's going to be y equals 2. But it's not going to be y equals 2. Okay, that's just the equation for the line. This one's going to be y, let's see, notice that all the y's shaded are less than, they're below the line. So it's going to be y is less than or equal to 2. Let's just make sure we did that one right. Oh, hold on, it's 4. I made a mistake. I wasn't looking at the scale. It's 2 units on the graph, but each unit is 2, right? So it's 4. It's 4. We're going to make that change here. Make sure you watch your graph scales. Don't make that mistake. I won't make that mistake twice in one video, I promise. All right, letter I. Now we need to graph this one. We need to write the equation for this one. I need an equation for this line. I notice that it crosses the x-axis at -5. So that means that the y-intercept it's going to be y equals mx plus b. Well, b is the y-intercept, which is -5. Okay, so it's going to be mx minus 5. Now I need to figure out the slope. So I notice it goes from, let's see, 5 here. We're going to go up 1 over 1, up 1 over 1, up 1 over 1. Why, this line just has a slope of 1 over 1 or just 1. I need to choose greater than or less than. I'm going to choose greater than because it's the region above the line that's shaded. Now, wait a second. I need to check this and make sure I got the right side shaded. I'm going to plug in 0, 0 and see if 0, 0 works as a solution. Is 0 greater than -5? Yes. So I did choose correctly. Now I can reveal my big answer. There we go. All right, now you know what we're doing. You're ready to do a problem set for next time.